Okay, YouTube, this is my last video on the transformations of functions, in which we're really going to use what we discussed in the last video to quickly sketch graphs of transformed functions or functions in general, knowing what we know about basic parent functions and transformations themselves. So for these two examples here that I pulled from my particular textbook, what we're going to do is we're going to identify the parent function that is associated with these given functions, lowercase and uppercase g of x. And we're going to describe the transformations that take place. We'll sketch a graph, and then we'll talk about how we could rewrite g of x in terms of the parent function f of x with transformations applied. So looking at g of x here, we have g of x equals to 12 minus x squared. And the first thing I recognize is this. We say that letter A here, we say if we had identified the parent function, we say that this is a quadratic parent function. The thing that gives it away is that we have a squared x here. And I'm actually going to rewrite this as negative x squared plus 12. I care to do it that way. So we say that the parent function f of x is our quadratic parent function here. In terms of what transformations I see taking place, well, what I want to point out here is essentially this. Because I have a negative as a coefficient on my x squared, what I see happening here is I've really kind of made my function negative. I'm going to say that this has a reflection about about the x-axis. And I'm also going to say this, it shifts up or translates up 12 units. And I can see that because I'm adding 12 to all the y values here on our initial function. So basically, if you can imagine the 12's not here, I can see by making the negative in front of our x squared here, that's kind of like making all of our y values negative. I just want to show everybody this. If we had had just this, and I took everything times a negative value here, we'd say that that's the same thing as like that right there. And that would be the same thing as, well, this is f of x. So that'd be like negative f of x equal negative x squared. Okay? So anyways, here's what I want to point out. We would reflect over the x-axis because we have a negative as our coefficient on our primary parent function here. And then we're adding 12 to all of the values, so it's going to shift it up 12 units. So in terms of sketching this, this is letter C. We'll go ahead and put in our xy coordinate plane here. And I know that this is going to be our basic parent function, which starts at 0, 0, goes up 1, right 1, okay, and happens to go up 1, left 1, just because we're supposed to know the basic characteristics of this graph here. This is the graph of f of x. What we want to do is have this reflected over the x-axis and shift it up 12 units. So if I were to say, okay, let's say that this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Our new function would start clear up here, and since it's reflected over the x-axis, I mean, if you reflected this first, it went up 1, right 1. It would go down 1, right 1 if I did reflect it over the x-axis here. So from shifting it up 12 here, I'm going to go down 1, right 1 to the right, down 1, right 1 to the left. So there's our reflection, and then our function after it's been shifted up 12 units, okay? We could rewrite this now, which was our goal here. Write the function g of x in terms of the parent function f of x. Now recall that our parent function here is f of x equals x squared. So how could we write g of x, which is this negative x squared plus 12, in terms of f of x? Well, I know that this x squared is our f of x. So the way we could rewrite this is really this. We could say, well, it's negative f of x plus 12. And now we can clearly see that this transformation is going to take place where we made our y values negative, so it's going to flip over the x-axis, and we added 12 to all of those, so it's going to translate or shift up 12 units. So now let's take a look at this function over here. We have capital G of x equals the quantity x minus 1, quantity cubed, plus 2. So describing its transformations and identifying the parent function, well, the first thing we want to do for part A is this. We say the parent function is our cubic function. Okay, that's our cubic function. We can go ahead and sketch it in. As a matter of fact, it starts at 0, 0, like all of our parent functions, goes up 1, right 1, like all of our parent functions, okay? I guess not all of our parent functions start at 0, 0, but they center there. And I also know the basic shape tells me that it goes through -1, -1, because it's an odd function. But here is our parent function of the cubic function that we need to know off of the top of our heads. What we want to do is say, okay, well, what would these do to transform this parent function? What would its new transformation look like? So in letter B here, let's describe its characteristics. If we know the parent function is x cubed, what would saying x minus 1 cubed do to our function, and what would adding 2 to it do to our function? And this loose 2 here, obviously, I mean, I'm going to tell you, is going to say it's going to shift up 2 units. That's going to cause it to shift or translate up 2 units. And because we have this minus 1 on our input here, it actually is backwards for horizontal shift. We're going to say it shifts right 1 unit, okay? I don't see any negatives out in front of this, so I don't see any reflections across the x-axis occurring, and I don't have a negative in front of our x value, so I don't see any reflections occurring in the y-axis. So in terms of sketching this function here, all we're really going to do is take all these original points and say, well, instead of starting at 0, 0, we're going to start right 1, up 2. So if I go right 1 and up 2, this point's going to be here now, and it has the same basic shape as the original graph since I had no reflections or no stretches. So I'll go up 1, right 1 from here, down 1, back 1, because I know the basic shape, and we'd say that this new transformation is really just going to be my original function here. And I should have done this in a different color. There we go. In which it's been shifted right 1 and up 2. So our last task here is to rewrite g of x, which is this x minus 1 cubed plus 2, in terms of our original f of x. Now, here's the deal. I have x cubed in the parent function, but down here I have x minus 1 cubed. So how could I rewrite this in terms of f of x to get an x minus 1 there? What we're really saying is this. We'll really say that this is f of x minus 1, where if we were to plug in x minus 1 into the original function, it would become x minus 1 cubed, and we say plus 2. So now we can clearly see that we have a right 1 shift, right 1, and we have an up 2 shift. Okay, with no stretches because we're just multiplying by 1 out front, and no reflections because this is a positive 1 times our y values, and we have a positive 1 times our x values. Cheers.